Okay. Hi everyone. Good afternoon here in Spain, or good evening, or good morning in other areas of the world. I am Oscar Bonastre, the chair of the Education chapter in the Spain section. I am also the section chair of the Spain section. And today the main goal is to continue with the series webinars of IoT and new frontiers in education. As we know, this event is organized in conjunction with Spain, Portugal, and Bangalore chapters of the IEEE Education chapter, also with the student branch of the UNED, IEEE HKN Nu, the Spanish section from IEEE, the Portuguese Society for Engineering and Education, and the REVA University. Today we have a really interesting webinar with the title Internet of Things and Practical Laboratories. The speaker will be Sergio Martín from the UNED, that Manuel will introduce later with a short video. And welcome everyone, hope you will enjoy. And I pass the floor to our colleague for Bangalore. Thank you.
Thank you. Siva, you can say some words.
Yeah, I welcome Professor Sergio Martin for this webinar series, and I would like to introduce the expert for today's talk. Sergio Martin is an associate professor at UNED. His teaching work is focused on the field of digital electronics, microcontroller programming, and IoT. He has 26 awards and recognitions in 14 years. In particular, to mention here, Online Laboratory Award in the year 2019, that is Global Online Laboratory Consortium for the best simulated experiment in the year 2019. He has a large number of patents. And yes, it's a pleasure for all of us to have Sergio Martin as an expert for the today's talk, IoT and practical laboratories. So the stage is yours, sir. You can go ahead.
Okay, I will stop sharing here. Thank you to all of you for being here, and you can now share the screen, Sergio. We have here today too Martin Llamas. Martin Llamas is the president-elect of the IEEE Education Society. In 2 years, he will be the president, and we welcome Martin. You like to say something, Martin? You can do it in any moment there. And Manuel, you can share the screen.
Manuel, I cannot share the screen.
Okay, sorry. I will bring you the...
Yeah, the permissions.
Yes.
Okay.
Now you can.
Now, can you see the screen now?
Good. Yes, perfect.
Good evening. Well, good afternoon. It's a pleasure to share this webinar with all of us, and I hope to enjoy this webinar series. Thank you very much.
Thank you, Martin. Okay, go ahead, Sergio. Your turn.
Okay, thank you very much. Manuel Castro, Martin Llamas, Dr. Venkata, Dr. Bonastre, thank you everyone. Thank you also to the IEEE Education Society, the Bangalore section for organizing this webinar series, and the rest of organizers. In this presentation, I wanted to talk about IoT and practical laboratories. And I wanted to organize my presentation around the 6 W's of IoT and practical laboratory: what, who, why, where, when, and how. So let's start with the why. Let's see the context of our work. We have been working on these topics during many years. And the reason is because we identified a lack of professionals in some sectors, such as, for example, cloud computing, where there is a lot of jobs unoccupied, a lot of skill training need from employees and from companies, and also from other technologies, such as, for example, Internet of Things. Which, for example, the European Committee estimate the market value of IoT in 1 trillion euros in 2020, just in Europe. And also there is a huge annual growth rate. For example, we can see how in 2014 there were 300,000 developers, IoT developers, and in 2020 the estimation was around 4.5 million. So this is a huge annual growth rate, and this is a massive market opportunity. But the truth is that most companies are not ready yet to implement these technologies. The same happened with when we talk about Internet of Energy, IoE, which is a particular case of IoT. It's more oriented to the energy sector, and basically we find the same problems. There is a lack of professionals in the sector, and there is a low level of knowledge of the technology. We find, on the one hand, electric engineers that do not have the knowledge from the communication part, cybersecurity protocols, and so on. And the same happened on the other side. The IT people don't know the technical knowledge. So at the end, there is a gap in the middle that for training, a training gap that is we have to help to fulfill. And the same happened when we have a look to the fourth industrial revolution, the Industry 4.0, which basically is made of many other technologies such as cloud computing, IoT, IoE, also others such as artificial intelligence, robotics, virtual reality, augmented reality, and so on. So we have identified that there is a training gap there for the small and medium enterprises, especially. If we have a look into the situation in Europe, we see that most of the sectors in European SMEs can apply in some way IoT or cloud computing or these technologies to increase competitiveness. So we have been working on this field of trying to help employees from companies and trying to provide these new skills to the companies to increase competitiveness. Okay, now let's talk about the what. Let's see what are the practical laboratories or online laboratories that we want to mention. And well, we all know that in engineering education, practical skills is key. We have to touch things and practice things to be able to learn them. And but now in the current situation, with this pandemic situation, and then probably after the pandemic, we will go towards a more hybrid methodology, not only purely on campus, but more blended learning methodology. We have to think, how are we going to teach these practical competencies online? And when we think of this question, the answer usually is through online labs, through virtual labs or remote labs or deferred labs or some kind of online lab. Basically, we can identify two main types. There is others, but the main two are these virtual labs, which is a purely software simulation, but it's online, it's a web-based simulation. And on the other hand, we find remote labs, which is also web-based, but is connected to a real equipment. Of course, both types are didactic resources, and they usually allow to interact with real environments today. When we say real, it doesn't mean only real equipment, real devices, real hardware. It can be also real IoT platforms. or real IoT protocols, or real IoT applications. Now I want to introduce this very briefly, the reason who are we working on these topics. We've been working in a series of European projects in these topics. For example, we started in 2015 with the InCloud project, which was devoted to cloud computing, delivering training to SMEs about cloud computing. Then in 2016, we started the Internet of Things for SMEs project. Then in 2017, the Internet of Energy project. And then in 2019, we started the Industry 4.0 project. All these projects have a very similar structure and common partners and a similar aim, which is deliver online free professional qualifications to increase European SMEs competitiveness. And in these projects, we provided online labs, virtual or remote labs, to allow these practical skills acquisitions to the students, which mainly came from companies. And the partner composition was mainly based on a research or academic cluster, then a business cluster, because we were focusing on SMEs, and also experts on vocational training. Okay, let's talk about the where. When we want to implement this kind of laboratories, you have to think where I'm going to host these laboratories. And we analyze the state of the art of the remote laboratory management systems available in the literature. And we find, for example, systems such as Lab2Go or Lila, iLab, or WebLab Devstore. We have also studied standards such as SCORM, LTI, or the new standard from IEEE 1876, etc. But in these projects, we find out that we had a very heterogeneous set of virtual and remote labs. For example, what I mean by heterogeneous, I mean that, for example, we had a desktop application, a virtual image, a simulator, a console-only program, a mobile app, etc. So it wasn't only common web-based laboratories, but it was a very heterogeneous set of laboratories. And also in this project, we had some other requirements because we wanted to maintain the platform the long term. So we defined that we wanted the platform to be open source and free to facilitate the maintenance, and also that the platform should support reusability and standards, such as, for example, SCORM, and also that the contents that we deliver in the platform have to be delivered with an open license. So putting these requirements in a box and studying the literature, we find out that the repository, the platform that we needed to use in this case was BISH. BISH is basically an open repository for open educational resources, which is very similar to PowerPoint, but the difference is that you can embed very easily any kind of external application inside of a slide. And also it has other features such as social network, authoring tool, etc. Here you can see there's an overview of the authoring tool. You can put different text and elements and visual elements, and also it has more advanced features such as videos, where you can indicate that in this moment of the video you can I want to show a pop-up with a virtual lab, or a pop-up with a map, or an interactive application, or whatever. It has some rich features. Okay, now let's see some of the IoT laboratories that we have developed so far. And for example, you can see here the Raspberry Pi simulator, or an MQTT protocol simulator, a Raspberry Pi virtual image, or a smart weather station. So we are going to have a closer look to some of them. In this case, this first one is the first slide of the smart weather station. It's just the first slide, and you can click on the arrows and do change the slides, just like in PowerPoint. But then in one of the slides, we include a real-time updating dashboard, where we can see the different parameters updating in real time: temperature, humidity, pressure, etc. Other features. And also another kind of application that we developed was a mobile app that the students install in their phones, and they connected to an IoT, a real IoT platform, such as UBDots. And then the students, when they save the phone, some data go from the phone to the UBDots platform. And then the student also can create events to trigger alerts and so on. Another example is, for example, the Raspberry Pi simulator, where basically the student can write Python code for Raspberry Pi, just exactly the same as they will do it in a real Raspberry Pi. And then when the students click the play button, a virtual panel with GPIO connectors appear, and the student can play with the pins. So it's interactive. So the student can see the output pins with a light, or they can click to activate or deactivate the input pins. And also there is a console here where information about the pins or whatever information that you want to print on the console. So, for example, we created several practices into a brief presentation, from easier to more complex, and the student click on these interactive buttons and open the Raspberry Pi simulator with the practice preloaded. So the student have to change the code or modify or add anything. The next application that I wanted to show is the, for example, the Raspbian virtual image, which is basically, we provided, you know, the Raspbian is the main operating system for Raspberry Pi. And so we provided a virtual image that the student can deploy on their computers with a virtual image visualizer. And basically, it's exactly the same environment that the student can find when they have a real Raspberry Pi connected to a screen. And we also integrated there in the virtual image just a GPIO virtual panel. So it was like a simulator, but interactive. So the students can click on the input pins and see the result of the output pins, and they can connect to external IoT platforms. So operate with the virtual image exactly the same as a real device. And also I wanted to show you some of the Internet of Energy laboratory that we also developed. As I mentioned, basically the IoT is the integration of the energy system with IoT. So here you can see 5 of the demonstrators that we delivered in our project. The first one is a small microwave laboratory where we have a prototype with a photovoltaic cell, an energy storage system, wind turbine, an electric car, some lights, motors, and we have an Arduino for data acquisition and control, and a Raspberry Pi for acting as a server. And you can see here in the screen the screenshot of the platform where the students will turn on or off each one of the components: the air conditioning, the house lights, contain the garden lights, the grid connection, etc. And in these graphs, the student could see the battery voltage, the battery current, and many other parameters that change when you turn on or off one of the elements. Also, another example was this intelligent smart meter, where basically it is a simulator that creates a random house with some consumer appliances. For example, with lights, coffee machine, electric oven, a hard dryer, a washing machine, a TV, and the simulator creates randomly or put or turn on and off these consumer appliances at certain hours of the day. For example, the washing machine during the morning, and the TV during the night, and the dishwasher during the afternoon. So this is a random set of for each one of the consumer appliances, and then the simulator allows the student to play and to move when the student wants to have this consumption. For example, I want to put the washing machine during the night, and then I want to turn on the lights only during the night. And then you can see at the end of the month, the electric bill, how it changes when you move the consumption of certain appliances from one moment of the day to another. And then another laboratory that we created was a smart meter connected to real devices such as a TV, a smart TV, a router, etc. And the student just having a look to the graph, they have to indicate or find out which one of them were connected or not, or in which state, maybe just as a standby or off. So it was just like a little game. And finally, this simulator, it was an MQTT protocol simulator for IoE. Basically, I don't know if you know, MQTT is one of the most popular protocols for messaging in IoT. So in this simulator, we have several elements such as an electric car, a washing machine, a microwave, and a light. And the student can turn on and off each one of them and configure the messaging system of each one of them. So they can choose the MQTT topic and the URL of the MQTT broker. So the student starts seeing all the messages from each one of the appliances that move from the element to the broker and back, and how the MQTT protocol works in an environment like this. And if you want to have a look and play with some of these laboratories, they are available here in this platform, bish.ieec.uned.es. You can have a look if you want. And also, I wanted also to show you very quickly some other related laboratories. They are not focused on IoT, but for microcontroller, programming, and so on, it's very related. I wanted to also to show you, for example, we created a set of practices using Autodesk Circuit, which is a commercial platform. So you can create, it allows the student to create the design of a circuit connected to a microcontroller, in this case it's an Arduino, and then the student can write the code for the Arduino and execute it in the code, and then see the results in real time. It's very, very interesting. It's purely virtual, but it's very interesting. Also, we developed around 200 virtual labs for digital electronics, and it's, in fact, we received several awards for this development. Also, we created a virtual lab to understand how a microprocessor CPU works when you execute a command, an instruction, what happens inside the CPU. And also, we have developed several remote labs for PAs, such as, for example, for the OpenFPGA ISUN Alhambra board, also for ceilings, also for a PSOC, also for a microchip microcontroller for a PIC connected to a pneumatic arm, also for a classic microprocessor, such as the Motorola 608000. And also we have created several remote labs for Arduino. In this case, this is a 3D LED cube, so a set of LEDs connected in a 3D cube. So the student can write the code and create light animations with the lights. And a similar experiment we have created for a sensor lab, where there is a lot of sensors connected to an Arduino, temperature sensor, barometer, accelerometer, light, etc. And the student have to learn how to write the code for these sensors, and they can compile and execute in a real code, and you can see through the webcam the result. And the final part of my presentation is the how. How we design these practical laboratories. Well, we follow the inquiry learning methodology. We participated in a project, in a very big project, European project called GoLab, which was devoted for taking for delivering online laboratories to schools. And in this project, it was defined this methodology where you have 4 stages. First, the contextualization stage, where you have to provide the instructions of the context of the demonstrator, of the laboratory. Then the orientation stage, where you provide clear instructions of what the student must do to use the laboratory. And then the third stage is just to play, to experiment with the laboratory. And the final stage, which is the conclusions, where the student can see the key findings in this experimentation. And in this final slide, I just want to show how everything fit together. We have a set of demonstrators that are in the BISH platform, as an open repository of laboratories, and everything is designed with this inquiry-based instructional design. So more or less, this is what I wanted to share with you today. I hope you enjoyed, and I am happy to answer any question that you have.
Thank you, Sergio, for the presentation. I believe it was really clear to have this in mind, all the things regarding this IoT and the environment for IoT and Internet of Things, Internet and Energy, and so on there. We have a couple of questions in the chat. If you like to make some question, please, you can do by two ways. First, using the chat window, using the questions and answers window, or you can up your hand in the attendance list, and I will allow you to mute the microphone and you can do by voice. The question we have now is that if there are some labs considering the security aspects, security attacks like DOEs, security countermeasures, etc., they are included in all those labs. They must be included, or what is your impression? Tomorrow we have a session with Elio about the security in general, but in this case of these labs, do you have in mind when you design this?
Yes, well, when we design these laboratories, particularly these, security is taken into account only from the perspective of safety for the laboratory. I mean, it's not designed to teach how to create secure application or learn how to create secure networks, but we have the security in mind only to avoid security problems inside the institution, because you can, for example, put a Raspberry Pi and provide a desktop, a remote desktop to any of them, but this is dangerous. This is very dangerous. So students can connect to your Raspberry Pi, and they are inside the institution network, and that's very dangerous. So we create the laboratories very carefully to avoid this situation. Also because most of our students are more from the electronic side, so they don't see the security very, very closely. But we focus especially on preventing security problems in the institution. But of course, there are many IoT laboratories in the literature, if you have a look for IoT, that you can find, and they focus on security. For example, I've been collaborating with one of them that provided like a console where you can execute just some commands. You cannot execute anything because it can be very dangerous. Just certain commands can be executed in this cell. So you can check the network and configure things in the network and secure the network, but in a very controlled way. You don't have permissions for everything, and you don't compromise the rest of the institution.
Yes, and when you have this kind of issues, you have in mind that you have several different layers. You have, for example, the IoT systems or the Arduino, Raspberry Pis, but you have the servers, and you have to make in all of the places, of course, you have to be in mind the issues of the security in all the levels there. Another question for the same person, for Ayman, is that if you can add or include security in an existing lab as a guest user. I believe not, because as a guest user, you can do nothing, but sometimes if you have a hole, you can go there, of course.
Yes, yes. Sometimes, depending on the kind of laboratory, you can provide a guest access or not, depending on the things that the user can do. Maybe it's harmful for the laboratory or for the institution. So it's better to have a more controlled user sometimes.
Yes. Other question from Saresh is that if you have any study done with respect to effectiveness, we talked yesterday about effectiveness of online virtual labs with real labs. I saw some articles in the journals, mainly in the Transactions on Education and the Computers in Education, where you have some studies about this kind of things. But I don't know if you know some specific or something like that in this area.
Mm-hmm. Yes, there are several. Of course, usually these studies provide good effectiveness and high satisfaction from students when they use these laboratories, because they have the laboratories 24 hours a day instead of just having access to a laboratory certain hours every week. So usually the students are happy, and the satisfaction usually is very high. And also, for example, we have been working on evaluating and comparing the use of virtual labs against more traditional digital resources, and the results are that the virtual labs are very positive, but if you provide too many virtual labs, at the end, students get very confused and it's worse. So you have to measure where you put the right quantity of didactic resources. Not for giving a lot of virtual labs is better. It's better at certain point. If you pass this point, it's worse.
And another question regarding security from Aymen too is that if there is no way to test security on IoT devices using the existing labs, so there is a way to try to do this kind of test security. Of course, you always can try to attack and try to see if they have really implemented the security or not.
Yeah, it depends. It depends obviously on how you design the laboratory. Totally depends on your design and how you create several you put firewalls and you separate the different parts of the network to avoid problems. But it depends on your design. For example, we try to avoid giving our devices too much connectivity. So we prefer that the students see results in a screen or something like that, or just access to a specific IoT platform, but giving access to many resources is dangerous. At the end, it's very dangerous, as we have to have it in mind when you design the system.
Mm-hmm. Thank you.
Professor Sergio Martín, yeah, do you have any industry partners for executing these IoT labs?
Well, these IoT labs have been developed within projects where also industry was part of the partnership. So they have been involved in the design, at least the conceptualization of the labs in the initial design. They were present and to give the inputs, because the industry was present in the partnership. But at the end, most of these labs have been designed by an academic institution, like institution. Yes.
Yes,
Okay.
we have one
Thank
more
you.
question about multi-user systems, because as you know, normally the major part of the labs, the internet labs, remote labs, are a single user. Other ones are multiple user, like Visir and so on. What do you say about the concurrently used by multiple users? I talked yesterday too about the farms. You can have parallel systems working together, or you can have some kind of the way of to have balanced systems or like federation systems. What's your opinion about the concurrency for multiple users?
Yes, in this laboratory, we can, depending also on your design, you can have several levels. From a laboratory where only one user access the resource and until we exit the lab, another student don't have access to the lab. To others where, for example, we have some of the labs that the students have to write code, and there are several stages. The write code and then several compilation stages. So we allow the students to be in one of the stages. So it's like a pipeline of the students in a stage. So at the end, it's not a student blocks the whole laboratory, but only blocks a stage. And then there are other laboratories, as Manuel mentioned, that allows concurrency. It just depends on the kind of laboratory, such as Visir, provides, I think you remember, 60 students at the same time. And also you can go if you have a high concurrency requirement, you can go to a virtual lab where there is no concurrency problem. It's purely virtual. So you can have thousands of students at the same time if your server allows it, or put it on the cloud. And also you have another way to do it with deferred labs, which are remote labs that are recorded. So they are remote, but they are recorded, so they become virtual. So when they become virtual, you can have, again, thousands of students at the same time, and there is no problem. So
multiple instances.
Yeah, you can, depending on your requirements, you can go to one level or another level.
Yes, and one solution there. Now we have connected in this conference to some people from the, as I told you, from the student branch in the UNED. We have the chair, the current chair, Pedro Plaza, that will talk on Thursday, and we have two, Felix Garcia Loro, that is the chair elected. And in the PhD of Felix Garcia Loro, we developed a booking system. Then you can have a booking system for the labs. You can put some slides, some time slides for each one of the users. And when you are moving these slides, of course, this is a single user, but you can program and having multiple slices of the system of the time for each one of the different users there using a booking system. This is another solution to try to have not a real multiple concurrent system, but like a similar concurrent system. For example, as I told you yesterday, the Visir system is a real multiple user, but at the final end, only one person can do at the same time to access to a same component. But as the system has a lot of users, when you are set up in the system and you're putting all the components and so on, then you have the impression that you are working on concurrent systems. But at the end, when one person say the test, only one person say test. But the test time is just some few milliseconds. Then you see the real a concurrency system are doing that. This is some solutions to try to do that. Osvaldo say that this is possible to use this approximation for real-time applications. Yes, the real time. The problem in real time is the definition of the slot when you have the answer for an instruction. When you send any kind of event in the systems, you must have like all these answers are in a minimum time there. Depending the minimum time, if you put a really strict minimum time on milliseconds or something like that for a real systems, then you can have only one user at the same time. If the answer is much relaxed, then you can have some kind of solutions in this area there. I don't know if you have some more comments about that or this kind of things there.
I agree with you. Also, it depends on the network delay. So depending on the real-time requirement that you have, probably you cannot do it through the internet because this network delay can affect your application.
Yes, this is the reason normally they have a specific network controllers when you are talking about real-time devices and so on there. We have another question, in this case from Pedro Luis Gonzalez, about is this possible to use a Raspberry Pi simulator to put devices in the network and simulate them? So to use that concurrently, you know, some kind of system that should be using this kind of network concurrent controller.
Yes, there are some examples from the literature of Raspberry Pi. Well, but they are not simulators; they are real Raspberry Pis that are organized in a cluster. So you can create application on IoT laboratories, making use of these network laboratories in the cluster, and also each one of the laboratories can deploy Dockers with more services. So at the end, you can have a very complex ecosystem in this cluster of Raspberry Pis. But as I mentioned, this is real devices. If you want to do it with a virtual lab, with a simulator, you can do it maybe with virtual images. It could be very easy to do, having several virtual images, as many as you want, and you configure the networks, and you can configure the things that you want to happen between them. This could be very feasible and not so complicated.
Yeah, one question, Sergio Martin. If we want to introduce these labs in to the 4-year undergraduate engineering program, should we introduce them somewhere in 4th semester or 5th semester? First question. And in how many semesters we should have these IoT labs? I mean,
I don't know your study programs. I'm not able to.
It's a
Not sure.
4-year engineering program, ECE.
Okay, so probably it should go to the 3rd or 4th year. Probably in the first year, usually you have more fundamentals of the subjects, and then you can specialize on something like IoT in the 3rd or 4th year.
Yes, in the specialization area, normally
Okay.
you need to have a lot of knowledge before of programming and networking and so on there to start to work in about that then.
Okay, okay.
We have a question from Pedro Fonseca about if the labs implemented are built in a common technological platform, of any lab can be in a custom development or a mix of both.
Yes, sometimes in our case, most of the cases is a custom development that we do depending on our requirements. Sometimes we make use of a framework, an existing framework that we find somewhere, but in most cases it's something that we develop from scratch for a certain application that we have this need.
Okay. I believe there are no more questions. I'd like to thank again for the working of all the people. I'd like to thank all the people attending. We have another colleagues like Antonio Robles, that is the secretary of the Spanish section, and we have Paco Arcega, that was a past president of the Education Chapter in Spain. We have a lot of people that was attending here today too. We have today, the maximum people I saw today was 60 people. That was really good attending the session. And I'd like to thank to all of you for the people there. Here, there is two people from Moncho Carrasco that was a past president of the student branch in UNED. And it was a real pleasure to have you all here today.
Thank you very much, everyone, for attending and for organizing this webinar.
Thank you very much, Sergio, for all the information and for all the questions and answering that you did it. You can close the session there, Siva and Oscar. Thank you very much. And tomorrow we'll have another interesting session about security and all the things regarding security in those systems and in the general part of the security for IT processes there.
Okay, see you.
Siva, you first, if you wish.
See you, bye.
Or, okay, I can do. Thank you very much for your attending. The webinar has been really interesting, and let's go forward with the rest of webinars for the rest of the week. See you tomorrow. Bye.
See you tomorrow there. Thank you very much.